47A is arithmetic sequences, and we're going to focus on a recursive formula for an arithmetic sequence today. We'll do an explicit formula on Monday. Okay, so it's two different types of formulas. A sequence is an ordered list of numbers that often form a pattern. So we're looking for a pattern. The term of a sequence, I'm recording, is each number in the list. Okay, so if you look here, 5 is a term, 8 is a term, 11 is a term. It's my first term, my second term, my third term, right? There's a sequence happening, and you have these term numbers. Richie, why so angry at the notes? All right, so what we're doing, and Joaquin, we're drawing figure eights. Just take notes, people, just take notes. So the first thing we're going to do is we're just going to look at these patterns. It says describe a pattern in each sequence, and then what are the next two terms, okay? Your calculator may come in very handy for you on these if you don't love mental math. If you're good with mental math, then you might not need your calculator very often, but it's nice sometimes just to have it. Stop drawing me pictures, people. Take notes. Just take notes. All right. I'm talking. So if I'm talking, you should be listening, not drawing is my point. Okay, so the idea is, how do I get to the next term? So if I'm at 5, to get to 8, and then to 11, and then to 14, what is happening? You are adding 3 each time, which means your next term is what? 17, and the one after that? 20. Okay, so those are the next two terms, and then the pattern is plus 3. Okay, look at the next one. 2.5 to 5 to 10 to 20. You are multiplying each one of those by 2. So times 2 is your pattern. And what are your next two terms? 40 and 80. Okay? So the idea is figure out what you're doing. Now, here's the deal. Some of you are going to see this and go, yep, I got it. I know what that is. But other times, it's just not that easy. So here are some good methods for you to employ if you're trying to figure it out. Okay? I always say, take the second term and subtract the first term, 11 minus 5. Then go to the third term and subtract the second term, 17 minus 11. If that number is a positive number, then we were adding 6 each time, right? If that number is a negative number, then we were subtracting whatever each time, okay? If addition and subtraction doesn't work, then try multiplication and division. Take the second number and divide by the first number. Take the third number and divide by the second. That would be what are we multiplying by each time then, okay? Does anyone see what this one is? I said it already. It is plus 6. You're adding 6 each time. So plus 6 is the pattern, which gets you what two numbers? 29 and 35. Okay, so give the next two and tell me what's happening. What are we doing on this one? 400 to 200, 200 to 100, 100 to 50. Okay, so there's two ways you could say this. You could say I'm dividing by 2, or you could say I'm multiplying by a half. They are both correct. It's whatever makes more sense to you. Khalees.
I hate the multiplying by half.
Then just do the dividing by 2, okay? So here's your pattern. 50 divided by a half is, divided by 2 times a half is 25. 25 divided by 2 is? 12.5. Okay, look at E. How do you get from 2 to negative 4, 4 to negative 8, or negative 4 to 8? You're multiplying by a negative 2 each time. Okay, so times a negative 2. You don't have to put the parentheses, but otherwise it looks kind of like x minus 2. So times negative 2. So what's your next term going to be? Positive or negative?
Positive.
Positive, 32. And then the next one? negative 64. Okay. How do you get from negative 15 to negative 11 and negative 11? You're adding, right? That number looks like it's getting smaller, but it's really getting bigger. So you are adding 4 each time. Okay, so plus 4 is the pattern. So what are your next two terms? 1 and 5. Okay, so patterns. Those are going to come in real handy with what we're doing in this section. We are mostly going to focus on an arithmetic sequence. Eventually, we'll talk, well, I don't even know if we'll talk about geometrics ever. We'll see. But an arithmetic sequence, okay? This is a sequence when the difference, what's a difference? Subtraction, okay? When the difference between consecutive terms, so terms that come one right after the other, okay? Your difference is constant. What does it mean to have a constant difference? It's the same. So like I'm adding 2, I'm adding 2, I'm adding 2. Would it be a constant difference if I said plus 2, plus 3, plus 4, plus 5, plus 6? No, right? The constant has to be the number I'm adding or the number I'm multiplying. Well, arithmetic is adding. The number I'm adding or subtracting is the same number every time. Plus 7, plus 7, plus 7. Okay? That will make what's called an arithmetic sequence. And in an arithmetic sequence, there is this letter D that is called your common difference. It is the number that you are changing by each time. Okay? All right. So the way that we tell if something is an arithmetic sequence is we check, does it have a common difference? Are we adding the same thing each time? So take a look at this. What are you doing to get to the next number each time? This is plus 5, this is plus 5, this is plus 5. So do you have a common difference? Yes. So we would say the question was, tell whether the sequence is arithmetic. This would be yes, this is an arithmetic. And your common difference is 5. You can do CD for common difference. Or if you know what, just do this. D is going to be the common difference. Don't do CD. Just call it D. So your common difference is 5. Okay, look at letter B. How'd you get from 6 to 9? Plus 3. How'd you get from 9 to 13? Plus 4. How'd you get from 13 to 17? Plus 4. Technically, you don't even need to know that. As soon as it's a different number, it is not an arithmetic sequence. Okay, it has to be the same change every time. Okay, letter C. How'd you get from 8 to 15?
7.
You're adding 7. How'd you get from 15 to 22?
7.
Plus 7. This is looking good. How'd you get from 22 to 30?
8.
Ah, not so good anymore. Plus 8. So if it's different, that is not an arithmetic sequence. Okay. Is D an arithmetic sequence?
Yes.
Yes. Why?
Plus 2.
You're doing plus 2 each time. So we would say D is 2. What if we were subtracting 2 every time? What's D?
-2.
A -2. Okay?
What if you divide?
Then it's not an arithmetic. So arithmetic is always adding or subtracting the same amount. Geometric is divide, and I don't know that we'll get to geometrics. We'll see.
What's multiplying?
Geometric. Multiplying and dividing is geometric. Adding and subtracting is arithmetic. All right, letter E. Is that an arithmetic sequence?
Yeah, it's -6.
You are adding a -6 or subtracting 6, subtracting 6, subtracting 6. So we would say yes, your common difference is -6. How about F?
Yeah.
Seeker, put that away. Put it away. That one you're multiplying, right? So you are multiplying by something constant, but it's multiplication. It's not addition, subtraction. So this is going to be no. Okay. Doesn't work with multiplication. Okay. So then there is this formula, which is called a recursive formula. And a recursive formula is basically taking a pattern, but you must know the term before it, right? So you can only find a recursive formula if you know the term right in front of it, which means if I say find the 17,000th term in this sequence, you do not want to use a recursive formula because you would have to go through all 17,000 numbers and it would be awful. Khalees.
For the arithmetic one, if this still has a common like difference or whatever, will we still write that even if it is no?
If it's no, then there isn't a common difference. So this one was multiplying by -1, but that's not arithmetic. Arithmetic has to be addition or subtraction. So you say no, so you don't write anything because there isn't a common difference. Common difference means we added the same thing every time or subtracted the same thing. Add a negative, however you want to think of it. Okay, so a recursive formula, okay? This is a function rule that relates each term of a sequence, so each number in our sequence, to the term before it. So you have to know the term before it to be able to find the next term, okay? So here's how these get written. This right here is the general setup for it, but in a, well, here, forget this. Don't box that. This is more the general setup for it. So it's going to be your A sub n. Now, the n's, the a's, the ones, the minuses, the d's, all of those can get really confusing. So just stick with me right now while I explain what each of those things are, or you're going to be really confused when you try to turn this into a formula. First of all, when you see A sub 1, okay, and that's how we say it, A sub 1. We made the 1 a sub number. It was below, right? It goes down. It's just this little teeny number. All that's saying is my first term is blank. Okay, so in this one, I'm saying A sub 1 is 7. That means my first term of my sequence is 7. The first number is 7, okay? Then you'll get this, and this is more what's going to tell you what to do. So this is the term you're looking for, A sub n. So let's think about this. If I said A sub 4, which term am I looking for? The fourth term. Now go here. A sub n minus 1. Well, if n is 4, then I'm looking for A sub 4 minus 1, which is A sub 3, which is the term before A sub 4. So all this is saying is what was your previous term? The term right before this, what was it? Okay, and then it'll be plus D. What are you doing to it? You're adding some common difference to it. Okay, let me show you with this basic setup. Let's say I have a 7. That is my first term. We call it A sub 1. If my formula says this, A sub n minus 1 plus 4, it's saying the previous term plus 4. So the previous term, 7, plus 4 is going to get me 11. So my second term, my A sub 2, is 11. I just added 4 to it. If I add 4 again, I get my next term. So that's 15. If I add 4 to it again, I get my fourth term. So if I say, what is A sub 4? Well, it's A sub 4 minus 1 plus 4. What is A sub 4 minus 1?
7.
A sub... It's A sub 3, right? It's my third term. Well, my third term was 15. So 15 plus 4 is 19. Okay? You take the previous term and you just add to it. Okay? Oh, that got janky. These are supposed to be over here. Is that how yours looks? Shoot. That's a bummer. Okay, so here's what you do. Okay, these are your steps for writing the recursive formula. You have to find the first term, and you're going to say A sub 1 equals whatever that is, okay? You have to find the common difference. That's your D. That's the amount you're changing by each time. And then you write that formula and then extend it to whatever it is we need to extend it to, okay? So here it is. Write a recursive formula for the arithmetic sequence below. Don't even look at the numbers yet. This is what every single one will look like. You'll say a sub 1 equals, and a sub n equals a sub n minus 1, and then it'll be plus or minus something, okay? This never changes. You will write this as the start of every single one of your recursive formulas, okay? Now let's think through what we're going to plug into that. What is a sub 1 for this sequence? It's the 70. This is your first term, your second term, your third term, your fourth term. So a sub 1 is 70. And then I say a sub n, so this unknown term is the term before it plus or minus something. How did I get from 70 to 77?
Plus 7.
I added 7. So this goes plus 7. This is your recursive formula. Okay? So now the question is, if they ask you for the 8th term, how do you get there?
Plus 7 8 times.
You keep going plus 7, right? So you're at your 4th term. What would your 5th term be?
98.
98. What would your 6th term be?
105.
105. What would your 7th term be?
112.
112. What would your 8th term be? 119. So your 8th term. So a sub 8 is 119. Okay? All right. Right. It's confusing because of all the little letters and numbers. But the idea behind it is very simple, right? Okay, so see if you can write down what this next one's going to be without giving any information. Pretend you don't even know these numbers yet. What do you know is going to be there? Did you write that? A sub 1 equals, and then a sub n equals a sub n minus 1. So the term equals the previous term plus or minus something. What is going to go behind our a sub 1? 3, your first term. This is your first term. So a sub 1 is 3. How did I get to my next term? Plus 6. Where does that go?
After the a sub 1 minus 1.
A sub n minus 1 plus 6. Okay, here's what I need you to understand. Those are all below, right? They're like a subcategory, a sub number, okay? So make sure you make those smaller and you drop them down a little bit, because I'm not trying to say take your A and multiply that by n minus 1. That's not what we're saying. We're saying this is our previous term. So that whole grouping is one number. Okay, now this one says, what is the value of the 9th term? How many terms do we have so far? We have 4. Term 1, 2, 3, 4. We want 5, 6, 7, 8, and 9. What's your next term, your 5th term? 27. What's the one after that? 33 after that. 39 after that. After that. 51. So your answer here is a sub 9. My 9th term is what? 51. Okay, so that's a sub 9. This is the recursive formula.
So for our answers on the homework, it'll be like this?
You'll put the formula, and then you'll find whatever term number they asked you to find.
Can't you just do 6 times 9?
No. Because you're forgetting that we didn't start from 0, right? We started at 3. So you're having to add 6, starting at 3, 9 times.
Can't you just do that and then subtract 3 though?
On a situation like this, that works, yep. But don't do that. That's the explicit formula. We're going to get there. Okay. This one, and then I'm going to have you do the last one on your own. Your setup should be a sub what?
7.3.
What comes after the a for this very first thing? A sub 1 equals 7.3. So you have your first term. Then you say a sub n equals a what? Sub n minus 1. The previous term, the term before it.
Plus 0.5.
And then you are adding 0.5 each time. So plus 0.5. Okay, so this is the recursive formula. You have 1, 2, 3, 4 terms. So we need 5, 6, 7. What's your fifth term going to be?
9.3.
9.3. What's your sixth term going to be?
10.
9.8. What's your seventh term going to be?
10.2.
10.3, right? So adding 0.5 each time. So then the last part of your answer is my seventh term, a sub 7, right? That's my seventh term is 10.3. Okay, you do the last one. Work that out, see what you get.
What time do you get out?
I forgot to record that part of it. I don't even know. What time do we get out?
Yeah, we get out.